Check out this smooth camera transition. Notice how the view automatically shifts to highlight the key moment when the player enters a new area. This isn't a default camera behavior, it's a custom script built using the Camera API in Worlds. Hi, my name is Velen, and in this Worlds Creator Academy tutorial, you'll learn how to script camera behaviors using the Worlds Camera API, create smooth transitions and focus effects, and optimize performance to keep your experience running smoothly across platforms. We'll show you how to design flexible, dynamic camera systems that work on mobile, desktop, and VR. So let's get started. Before we dive into scripting, let's talk about camera modes. These are the building blocks for how players experience your world. Worlds offers a variety of built-in camera modes, and you're not locked in to just one. You can mix and customize them to fit your gameplay. Let's look at a few examples. Third person follows behind the player's avatar. This is great for adventure or platformer style experiences where you want players to see both their character and the environment. First person puts players directly in their avatar's view, perfect for immersive gameplay or moments that require precise aiming. And there are many, many more, all of which you can explore in the camera tutorial world and the camera API example world. Camera modes set the foundation, but you can enhance them with custom camera controls. For the best player experience and for simpler onboarding, we recommend sticking to these established patterns rather than inventing new control schemes. Now let's configure the camera settings that make the difference between smooth, polished experiences and frustrating ones. Let's break down each setting and when to use it. Transition options like delay, duration, and easing create smooth camera movements between scenes or angles. You'll want to use them for dramatic moments like boss fights or cutscenes, but don't make transitions too slow or overuse them. Players might get annoyed. Offsets let you position the camera to the side, above, or behind the player. An over-the-shoulder view works great for shooters, while side views suit platformers. You'll want to test different settings like position offset, rotation offset, and vertical offset to find what feels natural. Speed controls like translation speed and rotation speed determine how fast the camera moves or turns. Slow cameras build suspense in stealth games, while fast cameras keep up with the racing action. If the camera movement is too slow, your players might get frustrated though, and if it is too fast, it's going to feel jumpy. Force Look At draws attention to important elements like bosses or puzzle clues. Use it sparingly because taking control away from players too often breaks immersion. Field of View, or FOV, changes how much players can see. You can widen it for speed sensations or narrow it for precise aiming. Extreme FOV, though, can cause motion sickness, so use it carefully. Far Clip Plane sets the camera's view distance. Longer distances work for expansive worlds with distant scenery, but too far can hurt performance. So you'll want to balance visual impact with smooth gameplay. Now that you understand camera modes, touch controls, and camera settings, let's put them all to work with custom scripts. There's one key thing to know up front. Camera scripts in Worlds must be local scripts. This ensures that they run on each player's device independently, giving everyone their own camera experience without affecting others in the world. Let's walk through how to create smooth camera transitions using the Camera API example world as our reference. So in this example, we're going to show you how to do a simple camera transition using TypeScript. We'll be using a trigger gizmo to detect when the player actually enters the area, and then once they enter it, we'll ping pong back and forth basically between two different areas and take away camera control from the player. So you see here, the player entered it, and now we're going kind of back and forth between these two different reference points, getting a better view of our target practice area. And again, the player does not have camera control during this time. It's completely controlled by script. So now we've seen how it works. Let's see how it's implemented. The first part is adding a trigger gizmo to your world. This is how we're going to detect that the player wants to enter this new camera transition mode. And then we will add empty game objects for the actual reference points that we will ping pong back and forth through. Initially, we have a server script. This is going to be our detection that the player has actually entered the world. And when we detect it, we'll assign our local runner entity to that player. And this way, our local runner will be run on the player's actual client as opposed to on the server. This local script then has our two reference points that we're going to be going back and forth through. And then in pre-start, we're going to cache those references so that we can use them later when we're doing this back and forth type of behavior. Then we have our start function. The first thing that we do here is we check that we're actually running on the client. If we're on the server, we don't want to do anything, so we return early. But if we're on the client, we're going to set up an interval such that every 3 seconds, we switch between A and B position. We do this using the setInterval API, and then our camera is going to be with the setCameraModeAttach API. Through there, we give it what position we want to go to, the duration, and the easing that we're going to use. You can see here that we're using basically a 1 second duration to ease into our new position using an ease in out easing type. And that's it. Just 2 simple scripts, and we've got a camera transition working. Next, we'll build a script that automatically shifts the camera to highlight a specific object or area, great for drawing attention during gameplay or story moments. So in this example, we're going to show you how to use the camera API to focus on a specific position on the screen and then allow the player to interact with that specific position. So here we're going into our trigger zone as before, but now we're focused on this position text. This position text is just a simple example showing that when you click on different portions of the screen, it'll automatically show what the position is in screen coordinates, basically 0 to 1, X and Y. Keep in mind that you'll obviously be able to customize this further, but this is kind of the basis for being able to create a focused camera interaction mode. So let's dive into the scripts and see how this works. So initially our server-side script, which will trigger our camera behavior, is the same as before. It's going to assign this local runner entity to our player whenever the player enters this trigger zone. And again, it needs to be assigned to the player because again, camera scripts, well, they run on the client. So now let's look at our local script. A little bit different. This time, we still have our reference positions, but we also have our text display that's going to show our position. In this case, when we enter the trigger zone, initially we set camera mode attach to our reference A position, which is where our UI is also going to appear in the world. And we also enter a focus interaction mode. This is a specific type of mode which disables most of the movement controls and other input controls that exist for the player and gives you as the creator full control, basically doing whatever you want with that sort of input. Here we're going to be listening to the focused interaction input started event, and when we get that, we're going to extract our screen position from it and display it on our text display. Keep in mind that this screen position is what you can then use to create your own custom interactions, such as swipes, holds, double taps, basically whatever you have in mind. This interaction event, if we dive a little bit closer with it, you'll see that it has an interaction index. This is how you know that it's specifically this input with this finger, as well as other things such as screen position, world ray origin, and other things. The most important one that you need to know about right now is screen position, which gives you an absolute position of where this input appears on the screen. So here we have the camera controls API. There's a lot of different stuff in here that I recommend that you check out on your own time as well that will allow you to customize your input. In this case, we're using the focused interaction input moved, input ended sort of events so that we can receive raw inputs and then customize them however we decide to use them in our own game. And that's basically it. By using focused interaction, listening to inputs, and easing our camera into our reference position, we were able to get the player to focus on a specific part of our game and then interact with that part as well. Now that you've built your camera scripts, let's make sure they perform well across devices, especially mobile and desktop. Testing and debugging camera scripts on mobile requires a different approach than VR development. So let's cover the best practices for ensuring your camera systems work smoothly on mobile devices. To test how your camera behaves on different devices, start with the mobile preview in the desktop editor. Then, you'll send your builds to an actual mobile device to test performance in real conditions. This can help catch issues that may not appear in preview mode. Beyond testing methods, there are specific gameplay issues that you'll want to watch out for. Camera collision can cause the view to shift in ways that you don't expect, like when the camera moves too close in tight spaces. You can disable camera collision when needed for smoother results. You'll also want to consider removing collision detection to allow the camera to pass through collidable objects when this creates better gameplay. Camera occlusion is when walls or objects might block the view as players move around. Try walking through your world from different angles to catch and fix any blind spots. You'll want to test by moving around common spaces and viewing from different angles to ensure objects don't unexpectedly cover the camera and negatively affect the player experience. Testing finds problems, but smart scripting helps prevent them. One common mistake is running expensive camera calculations every frame. For example, avoid checking the camera's position or rotation on every update unless it's absolutely needed. Reducing these operations helps keep your world running smoothly on all devices. With solid testing and a few performance tweaks, you're ready to deliver a professional, responsive camera experience. So let's recap our key takeaways for scripting mobile camera movements. You'll want to start by choosing the right camera mode for your world's needs and mobile constraints. From there, you'll leverage multiple camera modes with smooth transitions for a cinematic feel. And finally, you'll always test on real devices to ensure a smooth player experience. Remember, Camera systems and worlds work across mobile, desktop, and VR, so it's important to test your experience on multiple platforms. Master these mobile camera techniques, and you'll create experiences that feel natural and engaging on touchscreen devices. You've got the tools. Now go create mobile experiences that look and feel amazing. See you in the next video.